What's up guys, Aman Kapoor here today, and today we'll be discussing some of the most fundamental laws of astronomy and astrophysics, something you might have already learned in your science class, and that is Kepler's laws of planetary motion. By the way, if you haven't already, I recommend you check out my video titled Speed Up and Slow Down to give you some important background information for these laws. Alright, so Kepler's laws of planetary motion are really important to the fields of astronomy and astrophysics, and it's really good to know them. But what is this Kepler anyways? Not what, genius?
So Johannes Kepler was a German scientist in existence from 1571 to 1630, so a lot of changes in science going around on his time. He worked for another famous astronomer in Prague by the name of Tycho Brahe. He published his 3 laws in various books, including Astronomia Nova, Harmonicus Mundi, and the Epitome of Copernican Astronomy.
So what are Kepler's 3 laws? The first law is relatively straightforward. It states that a planet orbits the sun in an ellipse, with the sun at one focus of the ellipse.
If you want to see this more in depth, please check out my video titled Speed Up, Slow Down.
Now the second law can be a bit more confusing. This law has everything to do with the fact that a planet's speed is different at different locations during its orbit. But that isn't how the law is worded. Kepler's second law states that at equal time intervals, a planet will sweep out an equal area between its orbit and the sun.
If the reasons for the areas doesn't make sense, just think about what would happen when a planet is slowest and fastest. It would cover less distance when slow, more distance when fast. Now when you're traveling slow, you're farthest from the sun. You're at aphelion. And when you're traveling fast, you're close to the sun at perihelion. So when you're close to the sun, you'll sweep out a long, not so wide area. But when you're far from the sun, you'll sweep out a short, wide, fat area. These 2 areas equal each other. You see those 2 areas on my diagram? Those are actually equal, despite how they might look a bit different.
So now that we got that, let's move on to the third law. The third law is, in my opinion, the best. It's a mathematical equation.
So this is the equation for Kepler's third law. Its main use is that it allows you to solve for the period of the planet. That is the time it takes to orbit the sun. Given r, its displacement, m, its mass, and 2 constants, 4 pi squared, and g, which is just Newton's gravitational constant.
So those are Kepler's laws. Hopefully you have a better understanding of the basics of planetary motion. If you like that video, please drop a like down below. It would mean a lot to me. And feel free to leave any comments down below. Questions, thoughts, concerns, jokes, riddles, songs, anything. And I have many more videos coming soon, so if you want to see more of those videos and support my channel, please hit that subscribe button. Remember, you're the best.